All right, so hi everyone, welcome for coming. It's kind of late, so I decided let's just make the whole talk a big demo. So I'm just going to show some systems that we use in our game Descenders. We have a little bit of sun issues, but luckily I have some screenshots as well. So I'm going to try to do some zoom in stuff so you can read a bit more what's going on. So I have to make do, but it should be fine. It's like, I'm just going to show all the systems that we use. So for those of you that don't know Descenders, I'm just going to show a quick trailer so you have a bit of an idea what we're going for. So what I'm going to talk about is this procedural design, because we made a procedural downhill mountain biking game. So I'm going to show you sort of how we generate the tracks from start to finish, how we do the terrain and the paths and the stunts. So let's just sort of show you first what we're trying to make, what the game is about.
Watching, waiting, nothing's changing. Where we're going, the best is nowhere.
All right, so that's Descenders. So yeah, as you can see, it's like a downhill mountain biking game, and like I said, it's all procedural. So we have these levels that we try to generate, and it's basically we have the terrains, we have the trees, we have the tracks, the stunts, and the question is like, why did we choose to do a procedural game? And that kind of came from this idea that we try to create this sort of genuine extreme sports experience. So not necessarily a realistic sports game, but more like, what is extreme sports about? Or in this case, mountain biking. And it has to do with this kind of like exploration and freedom, and also having to deal with risks as well. So we kind of sort of try to design the game in almost an evolutionary way, where we try to let the game tell us what worked. And we were making these tools to generate mountains and to sort of generate the levels. And then at some point we started realizing like, hey, maybe we can actually run these tools at runtime and actually generate the levels on the fly. And that kind of just like, we kind of went with it, and it turned out to work really well. And what you get if you have these procedural levels and sort of the high risk, high reward thing, it almost becomes like a roguelike sort of extreme sports game. And these two genres just work really well together. So I would just like to show you now how we generate these terrains. So that's why I'm in Unity right now. So there's a lot of stuff going on here, but I'll just like try to show you it as quick as possible. So we have a basic like terrain shape here, and the tool that we use to generate these terrains is called Map Magic. And Map Magic is like, it's an asset we bought on the Unity Asset Store, and it's made by a guy, and it's sort of a procedural terrain generation workflow. So yeah, unfortunately I can't zoom in any further than this, so you probably can't read it too well. Sorry for that. But basically what we're doing is like a node-based system where we sort of like chain these blocks together, and we sort of say like, this is a noise generation, then we apply some change over it, and then you output it to like a Unity height. So what you have here generates this sort of basic terrain. So what I could do now is I could add some other noise, for example like this Voronoi, and then I just use that as the input for the noise, and then, well, if you go back, you see I have a very different terrain now. Now there's like these peaks and stuff. So this is sort of the basic shaping of the terrain. We use noise functions to generate the terrain. This is very common to how other people do it. So it's these are very standard practices. So I'll show you how sort of a basic terrain, what it looks like. So if you look here, this is sort of a basic terrain for the highlands area of the game. So what you can see is like there's these cliffs on the side, and it's sort of like a slow road down. And what I can do now is I'll add some textures. So let's see here. I'll enable the textures, and then I'll hit force generate. So now it's going to generate. So it's going to do all these noise generations, and then it's going to use the terrain data to apply textures to it as well. So basically what it has to do is it does stuff like, oh, when something's steeper, then you apply a rock texture, and when something, you know, it's just, again, you're trying to get the logic for the generation, and this is probably not readable because it's very dark. So if I zoom in a bit, then you can see it a bit, that there's like, oh, there's some rock texture here, and then it goes back into grass. So basically what's happening is, you can see here that now there's a lot more nodes going on here. And then if you look at this this basic terrain generation, then what you see is, again, you have these noise functions, the Voronoi, that's what we use for like the big pikes in the back. And we have some curves that we use to sort of generate the outer edges. So you see here that we apply a lot of curves before we do the noises, and that basically makes sure that we have this sort of funnel of a terrain shape, and then we have another curve that says like, oh, I want it to like slowly go down like this. So there's a lot of like a custom sort of forming of the terrain combined with the randomness of the noise, and that sort of generates this this basic terrain shape. I'm just thinking if I just maybe add like a little an extra light here, then maybe I can just, yeah, now it's a bit over bright, but at least you can see it now. So now you can sort of see that we have this basic sort of terrain shape. So this is all fairly standard, and I think where it really becomes interesting is when we try to do the path generation, the path finding. So I'm opening this other scene now. Let me just add the light so that you can actually see what's going on. Yeah, it's not very pretty, but yeah, it's readable at least. So as you can see, we have this path that's sort of being generated down the mountain. So the question is like, how do you generate a path? And that's where the real sort of interesting design challenge came for me as a programmer as well as a designer. How do you, like, when you try to design a level as a designer, you have these certain rules that you apply where you're like, oh, it shouldn't be too steep, or the curves shouldn't be too curvy, or maybe you want the curves to be straight. Like, there's these sort of design process that go on in your head. And the question is, how do you sort of teach these design methods to an algorithm so you can apply them on the fly while you're generating it? So basically what we do is we use the A-star pathfinding algorithm, and it's based on this paper called Procedural Road Generation in Games. If you want to know more about it, I can give you the link. So it's based on some research, and basically what you try to do is it's an A-star pathfinding algorithm, and the weights that you use to do the pathfinding, you apply real-world cost values to it. So, and it's actually very simple to get in your head. Like, when they're trying to make a road in the mountains, it's not really possible to make it go like straight down. They have these sort of cost values where it's like, well, we can dig a tunnel, but that's going to cost this much more money, so maybe we can sort of like twirl around it because we can't make the road steeper than this. So you have these sort of logical values, and then you just sort of try to calculate the cheapest way to generate a road. So it's literally the same thing going on here. So what you can actually see from the path is that there's, yeah, sorry, I'll just like, you gotta have to take my word for it. There's a bit of a higher area up there, and it kind of just sort of goes around it, because else it would have to, like, for example, go up. And I told the Pathfinder that you do not want to cycle upwards. So it really tries to avoid that, and it goes around it. And maybe then I can just like have a little image to show it a bit better. So basically what you have is the entire terrain is being divided into little areas, because I have to do it at a certain like grid-based level. I can't just use every pixel of the terrain. That's too much. So I have these sort of nodes on it. I basically pull a grid over the terrain, and then you can see that the steeper the terrain gets, the more red the blocks get. And the block color indicates the cost that it takes to move somewhere. So you can see that the steep areas are too costly to move. So it's gonna ignore them. And actually above that, you see that they're like small white cubes. That means it didn't even go there. Like it didn't even check that. So what I can do now is I can run the Pathfinder and see if you can actually see that with the sun. But let's try it anyway. So I'm just gonna like zoom out a bit and then enable the nodes, yeah, and then I'm gonna generate. So now it's gonna do the terrain generation, and then it's gonna do the Pathfinder. No, it's impossible to see. I'll show you then with another image. Maybe this one works. Can I zoom in? I think it's probably very hard to see. That's really unfortunate. So I'll just explain what's going on the screen. Basically what it's trying to do, maybe you can vaguely detect these like little blue lines, but what it's doing is just like, it's basically just like going down the path, and it's for every node that it sees, it's trying to check all the neighbors and see like, hey, is this one maybe accessible? Is this one maybe accessible? And it tries to get the best next node and the best next node, because it's kind of impossible to calculate every possible option, right? So that's sort of how A-star works. And then what you get in the end is it sort of generates a path down the hill. And if I have it here, then this one I can zoom in a bit better. So what you see now is that you sort of have this path down the hill, and then you can sort of stamp a piece of road on top of it. And let's see. And then what you get after that is this sort of path that's being cut out. Here we go. This path that's being cut out of the terrain. And so yeah, like I said, the trick here is to teach the real world design rules and sort of teach them to an algorithm and try to have the algorithm sort of do this for you. So if I change one parameter in the algorithm, then it's going to give me a very different result. And that's the cool thing about the procedural part, the fact that, you know, changing one parameter high in the chain of sort of nodes can have a sort of butterfly effect. So only changing the steepness can give you a completely different level. I'll show you that later. First, I want to talk a bit about how we generate the stunts. So now we have this path, right? We have the terrain, we have the path, and now we want to place some stunts on the path. And the question is like, again, how would you as a designer place the stunts on this path? So for example, you have an idea for a certain jump, and you know that if you maybe go 50 kilometers an hour, you're going to go way too fast to do that. So if there's this start with a part where you just like bomb the hill crazy fast, you know that it might not be a great idea to put it at the bottom of the hill because you're going to go way too fast. So again, this logic that you have as a designer, you're going to try to teach it to the algorithm and try to sort of make it learn the tricks that you would apply as a designer. And for that, we mainly need data. So what we have here is basically, so this is very zoomed in, but basically what we can do is along the path, we're going to do a couple of calculations and some predictions, and basically we're going to try to calculate how fast the player will probably be going at that point. So again, it's a bit of a prediction because you can't know for sure how good someone is, but you can sort of simulate the physics going down, and you know that curvature is going to slow you down because you have to brake in the corners. And then you can also calculate stuff like how much curvature is there like vertically, what's the slope of the terrain. that kind of stuff. And using all that information, you can actually generate these stunts using your sort of designer inputs. So I will enable the stunt features here. Now I'm going to hit force generate, and then it's going to generate the entire map with stunts. Let me just move this in the meantime. So what you can see here is that the nodes are starting to get a bit more cluttered. There's going to be more stuff. So what we first do is what we have here is the sort of the basic terrain generation that I showed you, like the noise, and then putting it all together, and then adding some like terracing as well to it. Then what you get after that is we're going to do the whole pathfinding thing. So we run the pathfinder, we cut out the terrain, we generate the stunt features, and then we're going to use that to do a bunch of texturing as well. And then basically after that, you're going to get the whole like terrain texturing and stuff. So let's see what it did in the meantime. Yeah, so here you can see that it's actually managed to place a bunch of stunts on the track. And a stunt like this is actually one that is designed by hand. And the reason we did that is because I was mentioning the sort of roguelike theme or roguelike genre earlier on. And basically, the whole point of a roguelike sort of game, if you're not familiar with it, is it's like procedurally generated, and you sort of have to start over every time you die. You start from the beginning, but you can't learn the levels because they're procedural. But you can learn the enemies that you encounter. So the NPCs in a roguelike game is sort of what the stunts are in Descenders. So this stunt is sort of designed by hand, and I'll show you. Yeah, again, I can't show you in Unity, unfortunately, but I'll show you here. So I can zoom in. Basically, it's like an asset that we make where we say, okay, so I have a stunt feature called RAM60 tabletop. Actually, I'll take the one that I just showed you in the game. That's the Canon one. That's nicer. So basically what we say is we define, this is all the information that we need to define the stunt, right? And so we'll say like how long is it, we'll say what the shape of the ground is, so whether we need to create some kind of bulge in the ground, some stuff about the height and the width, and then here's the most important part. This is where we set the prerequisites. And this is basically what I was talking about, these design sort of constraints. So it says, for example, the velocity needs to be within 43 and 60. Because if you go slower than 43, I know that you're not going to make it. But if you go faster than 60, you're going to overshoot it. So I also know that it should sort of be on a downslope. Because it's sort of a flat ramp, it can actually be very much on a downslope without sort of screwing you over too much. If it's a curvy ramp, you can't really put it too much on a downslope because you're going to fly all the way way too far. And obviously, I want to have some kind of limitation on the curvature of the track, because if there's this curve, then obviously I can't put it in the middle of a corner. So these are the design constraints for placing this object. And then here I just sort of define what kind of objects I want to spawn. So it's like, oh, I have a couple of models and at what position I want to spawn them. But basically what we do with that is we have this, this list with a bunch of sort of stunts that we defined for this environment. And it's just going to try 1,000 times or 500 times. You can define what you want. Basically, it's going to just, for 1,000 times, it's going to take a random point and a random stunt, and it say like, does this fit here? And then it says like, no, this is too steep. Okay. And it's just for like 1,000 times, it's just going to try to pick a random stunt and a random spot on the map. And every once in a while, it's going to be like, oh, hey, this one actually fits here because the speed is all right and the curvature is all right. Cool, then we place it there. And that's how we basically generate, that's how we generate the stunts. And it works really well, and I think especially the velocity prediction is very important for that, because if you would just randomly place the stunts, then you're constantly going to run into jumps that you can't make or that you just sort of overshoot. So I feel like having this sort of fake player that sort of rides down the track and analyzes the possible velocity at that point, I think that really helps with that. So let's see what we can do after this. So yeah, so I showed you the sort of that it's starting to get a bit more like cluttered. We also have some other tools that we use to sort of spawn the start and the finish line, and we have these checkpoints on the track as well, and we need to make some room for that as well, because we can't have the start or finish on this on a weird like slope or on a weird bulge. So we sort of flatten that area as well. And then it's basically already time to go to the final phase, and that is adding the foliage and the sort of trees and rocks, that kind of stuff. And again, this is using very similar like regular noise and scattering patterns, so that's not too sort of fancy, but it's cool to show sort of what it looks like. And now you can see, because we're adding trees and rocks and little castles that you can run into, it's like a sort of Scottish Highlands area. You have little hay bales rolling around, that kind of stuff. And then you can see it starts to become quite a mess. And this is, I mean, to be honest, it's kind of hard to manage this. And then you can also see that we're kind of pushing the element, or like we're kind of pushing the boundaries of what the system was built for. It's just like a script that you use to do some generation, and we just have this complete mess of all these nodes. And sometimes it's a bit hard to keep track of it, and the editor gets a bit more laggy and stuff. But this is all that there is to it, right? And what you can see is what we've added is a lot more of these blocks, these like long blocks. And what they basically do is they scatter something, and then they do some position adjustments, and then they do some cleanups based on the paths. And I think what's important here is that obviously we can't just scatter rocks around the terrain, because you're going to get rocks on the path. And that's sort of the final step there, is we have a lot of masks that we apply to clean up these scatterings, because we want to make sure there's no rocks on the path, or within a certain boundary of the path. We want no trees, that kind of stuff. And then what you get is this beautiful thing, and I'm gonna make it nice and over bright so you can read it. So now we have like a nice full terrain, right? So, and as you can see, we have some trees, we have some rocks, some hay bales, and then we see the stunts also that we placed earlier. So so that's sort of the whole generation from start to finish. And what I would like to show you now is sort of the variation element of it, because that's the funny thing, right? We have this sort of track, and the idea is that, of course, every track should feel different, and when a player does a new track, it should be like a whole new experience. So let's see, if I go to Map Magic, then there's a terrain height value. Well, you can't see it, but it now says like it's 330 units high, the terrain. So now if I change this to, let's say 500, and then I run the generation, this is going to take a bit longer now, of course, because we have, first it's going to do the shaping, then it's going to do the pathfinding, it's going to place the stunts. Oh, there you see, like it already generated a path. So you can see now, okay, this is the path. Then it has to place the trees, the rocks, all that kind of stuff. Luckily, it's all multi-threaded, and I think the Unity editor doesn't do that. But or at least, oh no, it works, but at least it's way faster if you do it in the executable. So that's great, because we wanted to make sure that people don't have to, because this is every level, right? It's just one level of a square kilometer. So we wanted to make sure that people don't have to wait half a minute for generating their levels. So we really try to optimize all the function and the maths and the pathfinding to sort of generate in less than 10 seconds. That was really important to us. But now you can see that the track is very different. Like, for example, the stunts are completely different. The ones that we have here now are a lot different than the ones we had before. And the funny thing is, now you see a lot of the cannons that I showed you earlier, the cannon jump. And the reason we have a lot of these is because it's steeper, so the terrain, like the player goes faster. And these jumps work well at high speeds. And before, we had this fun box kind of thing, this pyramid, which was just like wooden and a flat part. And that one works only if you go less than like 30 kilometers an hour. And if you see the sort of the color of the line indicates the speed, and the red line basically means we're going, 50, 60 kilometers an hour, or at least that's what we expect that we'll be going. So it's funny to see that changing one value high in the chain generates a completely different level, and because of that, certain stunts will no longer appear, or other stunts that were otherwise not doable will now appear all of a sudden. And I think it's also cool to show like a different path curvature. Let's see here. So I go to the Pathfinder parameters, and then that one says, I prefer to have paths angled with 45 degrees. So it wants to have a bit of curvature, but not too much. So if I turn this into like 80, and I say that it's allowed, there's also like a maximum angle value, which says like how steep can the curves be. So I'll say like, oh no, 120 degrees, that's fine. Well, it's a bit too much, right? But yeah, so now let's run the generation again. And then let's see what it comes up with. And I hope, but I'm kind of certain that it will have a very different path, because there's this big straight part there at the top, and with these new values, that's going to be way too costly to do. So it's going to probably not take that straight path, and it's probably going to have a very much more of a swaying path, because every time it's trying to make these very, there you see it already. When the generation is done, you'll see it a bit more clear. So now it has these very sharp turns that are way too sharp to actually be fun. So that's where the designer comes in as well. You have to tweak all these values. So the challenge is very different as a designer. But now you can see, like, yeah, this is a completely different terrain. Yeah, so look at this. This is ridiculous. But yeah, you can see now it's just like, whoa, 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 all over the place. Because with every node that it's traveling, it's trying to create at least an 80 degrees turn, or that's like what it's trying to do. So you can see this is a completely different level. So it's just like one value that I changed, which says, curvature, make it a bit higher, and then you get just a wildly different result. And that's really what I think is the fun as a designer and a programmer on this project. It's sort of, I don't really know what's going to come out of this, but I try to build the systems and I try to build the designer logic, and then it's just a matter of experimenting with it and then seeing how many results you get. So for example, I built this tool that would just generate levels over and over again and then take screenshots from a couple of angles, and then I would just leave it running at the office, and the next day I would show up and then I would just scroll through the screenshots, and I could see like thousands of levels, and I could see all the different possibilities and edge cases, and obviously things that break, because this is going to get you edge cases with our players. So we have this tool in the game where if you encounter something broken in the game, you can report the level, and then everything is built upon a single seed. So we have this database with, well, hundreds of levels that are broken, because they're like, there's a tree like in the start line, and that shouldn't happen, of course, but for some reason it happened. So then they write a little message like, hey, there's a tree in the start line, and then they submit it. So we get the seed and we get the error, and then we can browse through it, and then we can see these sort of patterns that are occurring, like, hey, it seems like, so it's more like you're trying to see the bigger thing that's broken, not necessarily fixing these single issues. But then you can see that, for example, in the forest area, sometimes the path would intersect with itself, and you wouldn't expect the Pathfinder to find that the cheapest route. But then what would happen is like the game would try to make a path that would go through itself, and it's completely broken. So yeah, with that I'm going to wrap it up. And if you have some questions, that's cool. Like maybe I can show you here, but also you can just come up to me and talk for a bit as well. Thank you. Yeah, there's a question in the back.
Thanks. I have a question about sort of testing. I mean, you generate this randomly. You use your users basically to test them, to report bugs. But have you thought about maybe doing simulated runs? I mean, you use simulation already to determine speeds or possible speeds on the track. Have you also experimented with maybe an AI that you just use to check your generated levels?
Yeah. oh, that's an interesting like next step to take. And I think
In that case, I copyright it.
oh, really? Oh, in that case, we didn't. No, but no. But it's like we have to find the middle ground between sort of us testing stuff and us making the game. So that's like the hard part, because we're a small studio and we're only 2 programmers. So the biggest thing for me was to just like sort of run the simulation and generate screenshots, so I could just like have a look at the kind. Because the thing is, I can generate now and then I can wait and generate again and I can wait. So, but it's nicer to just have a script that generates levels and then in the next morning I check the screenshots. But I could take it a step further. But I don't think we are the kind of studio or we have the kind of audience to do that, because this game is on Steam Early Access, so it's sort of part of the game that we're still working on it, and it's actually really fun to involve the community, and I really enjoy like breaking the game and then being like, oh, I found this bug, and I'm like, no, and then we just launched an update and now we have to fix this in the weekends. So it's kind of a different workflow, but I like it. It's very just, you're sort of working together with the community. Yes, here in the front.
Do you also have rules to improve the gameplay? You have a lot of rules of the velocity shouldn't be too high, too low, but maybe to make it less predictable, or?
Yeah, I mean that's hard, because like do you have something more specific about improving the gameplay? Because
well, maybe do a stunt after a sharp turn.
Oh,
on
like
purpose,
that.
because it's a surprise.
Yeah. So the funny thing is that these surprises actually come natural. So for example, I was telling that we have hay bales on the track, right? And we give them physics, so they roll around basically. They roll down the hill, and we just scatter them on the track, and we just randomly place them on the track, and they start rolling down the hill. And just every once in a couple of plays, you'll be playing, and while you're like racing down, this hay bale just comes like rolling on the path, and you're just like, you barely miss it, or you just crash full into it. And it feels almost like it's scripted in a way. So funnily enough, because of the randomness, these surprises kind of happen automatically, and you just have to create the leeway to let it happen. So you have some leeway, and for example, there's also, people can choose what kind of levels they want to play, and they're basically on a big map, and then they can see like, oh, this one is a lot steeper, this one has more stunts. And for example, if you pick one with more stunts, then we give more leeway in the prerequisites of the jump. So it will be allowed right after a turn, or it will be allowed in a bit more of a steeper area. So you get more of these surprises. So I think we sort of do it, but we don't script it. It's more, if we allow the randomness to sort of do its thing, these things just happen, and that's really like fun.
What is the technical cap of like maximum amount of props that you can place in there? Because it seems really fast now, but what if you would want to make, for example, this track in the forest area just completely surrounded by trees? Is it possible?
I don't know if you're talking from a generation perspective or from just like a rendering perspective. Yeah. So the funny thing is, like spawning a lot of stuff is actually not that hard. The hardest thing, the biggest sort of impacts to the performance or like the generation time is like the sort of pathfinder. I think that's that's what takes the longest. But sort of scattering objects is very cheap. However, unfortunately, rendering a lot of trees is very expensive. So we've been running into a lot of issues, especially in the sort of this dense forest area that we also have, with rendering all these trees. And we're using Unity as well, which is, it's not a custom sort of pipeline. So it's really easy to scatter a bunch of stuff. To render it is actually a lot harder. So that's usually where you hit the limitations, and not even really the generation time.
What is the limitation?
Oh, what is the limitation? So I mean, I can look it up for you right now. Like, you mean like sort of how many objects we spawn, that kind of stuff? So I mean, yeah, why don't I just show you? So I'm gonna open the forest scene, and then I'll just hit generation. And then I can see here that, for example, these trees have a density of 4,000. So that's like 4,000 trees, 500 bushes, 600 grass ferns. Let's see, car wrecks. We know that's not really a big thing. There should be some more trees here. Or is this the main one? Yeah, I think that's the big one, yeah. So it's like about 5,000 trees, that's what you can do. And then I think it's done generating. This is sort of what it looks like. So from the, I'll add another light so you can see it. So I think the other problem is that you have to use a lot of loading and performance optimization to even render it like this. So you can see now that it's very cold, right? There's not many trees, and if I go down, then it starts going to the better quality models. So yeah, I mean, it's kind of over bright now, of course, but so this is sort of the kind of density that you would be looking at for a forest, and we had to sort of lower it and lower it until it was barely on this edge where it's like, if I do even lower, then it doesn't feel like a forest anymore, but if I do higher, we can't render it. And I have to tell the artist, like, no, it needs to be lower, it needs to be lower. The frame rate is like, we have no frame rate left. And it's like, come on, can't we? So it's this fight between the performance and the visuals.
So how do you prevent the Pathfinder from ending up with a very cheap but very boring track?
Sorry, can you repeat it?
How do you prevent the Pathfinder from figuring out a very cheap but very boring track?
All right, yeah, that's a good one. I spent a lot of time in the beginning trying to figure out this pathfinding issue, and I think the main trick to do is, first of all, you need to have an interesting base map. In some cases, it's not even like very special. Like the forest one is very straight, sort of like funnel. But if you go to this canyon area, I'll generate that in the meantime just to show you. And then, because this one has a bit more of a rugged look, so let's just wait for it to generate. And the trick is to tweak the values in such a way that it forces to do interesting things. So the cheapness is something that I have to define, of course. So that's why, for example, I always use this preferred curvature. So it's actually not trying to make a straight path. It's actually, I'm forcing it to sort of take these curves as well. So if you tweak that properly, then you can make sure that it's, makes a sort of realistic path, but it's also forced to generate interesting tracks. Because if I don't do that, then it will basically just do a straight track down the hill, and we don't want that, right? That's true. So it's again, because I have to program these values, then I have to sort of teach it to take this risk as well. So, because if you look here, you can see that this is a much more rugged terrain, right? This is the canyon area, and basically it's very steep. But if you look at the path, then you can see that it's being funneled by these like steeper parts. So it's sort of following the shape of the terrain, but you can see that within the sort of leeway that it has, it's doing some little curvature as well. So you're sort of forcing it to be a bit weird, but not, go too crazy. And the cool thing is this is the basic setup, and like I said, you can have this steeper or less steep, more curvature, less curvature, and if you start sort of pushing these values, then it becomes crazier and crazier. But then that's what the user's sort of asking for, so then it's fine if the turns are maybe a bit crazy, because they chose this super hard level.
Out of curiosity, how did you get A* to make loops?
Oh, that's okay. Yeah. Okay, that's a good one. Because it's actually so the thing is that obviously the idea of A* is that you have one value per node. So for every grid cell there should only be one value. So it should sort of be impossible to go through a grid node twice. So the big thing is that the basic implementation of A* doesn't take curvature or like turning into account. So it basically says like, if I take this way all around, or I take this way, then it realizes, oh, this is way shorter, so I just discard all this stuff. But the problem is that if after that we want to go this direction, if I take this way around, it's just a straight path, and if I go like this, it's actually a very tight turn. So in order to store the sort of the cost of the curvature, I need to store multiple values per cell. So every cell basically holds, I think it's like 8 directions. So it's sort of a 3-dimensional grid basically. So for every cell in the Pathfinder, there's 8 directional values. So it can sort of try from multiple angles, because also like if you go this way around and you say like, hey, this is not possible, maybe this way is actually cheaper, but then this node is already discarded because we already checked it. So that's how you do it, but then yeah, then you open up the possibility for it to sort of loop around itself. All right, I think that's the final question. Thank you so much for coming.